All right, you guys. So today we're going to talk about section 7.3, and that deals with unit rates and multipliers. But I just put a couple of quotes on that I found that I think are really kind of relatable to what we're doing. So I just wanted you to see and recognize the importance of what your job is and what you're doing and why you need to understand it. So proportional reasoning is both the capstone of elementary mathematics and the cornerstone of higher mathematics. So proportional reasoning is used from when students are young all the way through that progression of their mathematics career. And in real life, there's a lot of real life situations where proportional reasoning is used. So if we don't get these concepts down, so there's strong conceptual understanding when students are young, then they're not going to have it when they're in middle school, when they're in high school, and in real life. And I think a good example of that is a lot of people don't understand fractions. And they will, because they were never taught fractions at any kind of depth of level. It was just like, here's how you add them, get a common denominator. Here's how you multiply them. Here's how you divide them. And it was almost like memorizing how to do that. And it really wasn't about, drawing these models and doing parts to whole and bringing in some hands-on manipulatives and writing about it and communicating about it so you knew that students understood what they were talking about. And that's a good example. I still have students say, I can't do fractions. And then they went through the 1100 and they were like, I never knew this. I never knew that's what this meant. So you have such an important job as teachers. And so I just want to emphasize that. Just be proud of what you do and work hard at what you do and really, really be passionate about the success of your students. Another quote, if students cannot learn the way we teach them, then we must teach them the way we learn. The way they learn. So when we try and teach it, like sometimes when I first started teaching, I'd bring candy in. I think, oh, this is cool. They're going to love this. They didn't get it still. They weren't all that excited about it. Some people couldn't eat candy, and then they ate it, but they didn't see what the purpose of it was. And so I learned through my career that I liked that. I would love to do pie charts with Skittles, but not all students can. So I had to find a way that my students would learn best. And so when you go in prepared, you need to have a plan A, plan B, plan C, where you have these different options for students to try. And even though, you may think about your instructors, who some of your favorite teachers are, and how they taught. Well, some of your favorite teachers might be those who just lectured. Some of them, some others of you might have teachers that you got to get in your hands and create things and build things, and that's how you learn. So it doesn't hurt students to learn multiple ways to do things, but when you do that, you're gonna touch on the best way that they learn. So never ever go into teaching something one way. Always have backup plans with at least multiple ways to do it, with at least two and more if possible. So I wanted to share with you this, and I think this is really important. So without manipulatives, children are too often lost in a world of abstract symbols for which they have no concrete connection or comprehension. They don't understand. So when we talk about, I'm going to have you read an article on the equal sign. Well, that's a symbol. But there's a lot of meaning behind what the equal sign means. But if they only see it as a symbol, they're not going to be able to connect to what it actually means, to anything concrete. All right. And so manipulatives are really important. And I use manipulatives at every level. I use them as an elementary teacher, as a high school teacher, and as a college instructor. And so I really believe in this hands-on learning instructional cycle. And I hope that you take to heart what it's saying. On a hands-on learning instructional cycle, what it is saying is students need to be exposed to all these different types of learning. So yeah, maybe it's a standard algorithm, which is just doing, now this isn't a standard algorithm, but a standard algorithm is just taking 12 times 14, multiply, when you carry over and so forth. You borrow when you subtract. That's the standard algorithm. Now notice this, how the way that this is multiplied. So this is all about your place value. So 2 times 4 is 8, okay? And then 4 times 1 is the tens place, so we have 40. 1 times 2 is the 20, because that's going to be here in the tens place. And then 1 times 1 is going to be 100 in the hundreds place. So, and then you add that together, it's 168. That's a different way to multiply rather than the standard algorithm, right? So numerical is one way, and there's different numerical ways that students can multiply. All right, there's the box method. There's so many different ways that you can do that. You learn that in 1100. So numerically, we can do that. But we can also do that with hands-on manipulative. So these are base 10. These are base 10s. We can use these base 10 blocks, kind of a three-dimensional thing that they can look at. And then we also have this two-dimensional where we draw out a model. All right, it's not modeling three-dimensionally, but modeling two-dimensionally. And then if possible, trying to connect it to a real world that they might understand is another thing that I would include on this learning instructional cycle. All right, so when you make a lesson plan, try and as best you can. It doesn't always work, but try and get some type of as a 3D model if possible, something they can draw out in a 2-dimension, and then something numerical that connects it all together. So these can all be connected, and just look at the different types of understanding that they have to do to be able to understand that. So when students are exposed to hands-on learning on a weekly rather than a monthly basis, they prove to be 72% of a grade level ahead in mathematics. That's a huge, huge percent. And it's because they're doing hands-on learning. They're getting their hands in it, they're understanding concepts in multiple ways, and they understand it and they remember it. When they have hands-on, they remember what they did, and there's that retention as well. So just keeping that in mind, whenever you are building lesson plans, which is not going to be long when you guys are teachers, think about this hands-on learning cycle. It's really, really important. And again, I would throw in some real world context or connection too, if possible. Now, you can't do that for every single thing, I get it. But when you can, do that, and as often as you can. All right, so let's go ahead. I'm going to stop sharing there. Let me get a new share, and let's go ahead and bring the camera up here. All right, so let's go ahead and talk about some unit rates. So what I want you to first of all recognize, I'm going to try and get this so I can, is that when a unit rate is talking about one group. You're reducing your ratio to one group, whichever it is that you're talking about of your two groups. Sometimes it's 3 if you have a 3 ratio, but what we're dealing with is 2 ratios. One of those groups is 1, and that's a unit rate. Unit rate stands for 1. If you can remember that, unit rate is the same thing as when we talk about a constant of proportionality. Now, in 7.4, we're going to talk about the constant of proportionality, and it's the same thing as a unit rate. So I'll connect that a little bit more on 7.4 when we talk about that. But let's focus right now on just with the unit rate. So let's say we have a problem that says Rich runs, let's say you can go 5 meters every 2 seconds. Okay, so you can go 5 meters every 2 seconds. So we have a ratio of 5 to 2. Now, let's go ahead and draw that out on a double number line like we did before. So again, with a double number line. All right, so if we have 5 meters, let's go ahead and put the meters on top, and we can put the seconds on the bottom. And that doesn't really matter. I usually just take the bigger one and put it on the top. So here we're going to have 5 meters, and this is going to be 2 seconds, right? That's our proportion or our ratio. Now, what I want to do for a unit rate is, depending on what my question is. So my question I'm going to ask is let's do how many meters can he run in 15 seconds? So that's a question I have to answer. So would you agree, kind of went off the thing there, sorry. Would you agree that if I knew what 1 second was, that would be pretty easy to find 15 seconds. Yeah. So let's do that. So let's go ahead and let's see if we can figure out what 1 second is. So I want to know what 1 second. Well, what did I have to do from here to get 1 second? Well, I had to take this number and I had to divide it by 2. So I had to divide it by 2. So I took 2 divided by 2. So in order to get this number, I'm going to have to do the same thing. I'm going to have to take 5 divided by 2. And so 5 divided by 2, if we just leave it as an improper fraction, is 5/2. All right, so what I found is I found 1 unit by dividing this by 2, whatever this number was. If it were a 6, I'd divide it by 6, but then I'd have to divide the other by 6. So that means 1 second is equal to 5/2 meters. So he can run 2.5 meters in 1 second. So can I figure out then how many he can do in 15 seconds? Is that going to be a difficult thing to do once I know what 1 second is? So I'm going to do a ratio here and do a proportion. So here's seconds and here's meters. So let's say we have 1 second is 5/2 meters. So tell me then, if I know, if I want to find 15 seconds, how am I going to find how many meters? Now, this could look like a really difficult proportion with a fraction in it. So if I were to cross multiply, if I was a little bit higher level and I wanted to cross multiply, I'm dealing with a fraction. That's not always easy. But here, all I need to know is that if I have 1, how did I get to 15? Well, I multiplied that times 15. So then what I need to do here is I need to multiply this times 15. So I'm going to take 5/2 times 15. And I always have my students just put that whole number over 1. You don't have to. And then you multiply straight across. So that's going to be 5 times 15 is 75 over 2 times 1 is 2. So X is equal here to 75 over 2 meters. Now, if I want my final answer, I might want to go ahead and put that into a mixed number. So let's see what that would be. So if I take 2 into 75, half of 75, okay, 6. Bring down, 2 goes into 15 7 times with the remainder of 1. So 37 1/2 meters would be your answer for that. Okay. Does that make sense? All right. It's hard for you not to talk back and me to listen here. Okay, so let's try another one. So let's say how many seconds would it take him to run? Let's go, let's do 24 meters. Okay, so how many seconds would it take Rich to run 24? Keep going off the page, off the thing here, sorry. There we go. So how many seconds? So let's do number line again over here. So let's do a number line. Here's our meters. Here's our seconds. And we go with our original, right? Let's go with what our original 5 meters to 2 seconds. So we kind of start with the same. Well, now what I want to know is, I want to know 24 meters. So if I knew 1 meter, right, then that would make it a lot easier to determine how many seconds. So I want to know 1 meter. So instead of doing the seconds, I want to come over here and I say, well, how do I find 1 meter? Well, what do I have to do here? I have to take 5 divided by 5 to get 1 meter. So what am I going to have to do here? I have to do the same thing I did up here. So I'm going to take 2 divided by 5. So that's going to then give me 2 over 5. Don't put it in a decimal, just leave it like that. So what I found then is that 1 meter equals 2/5 seconds. So it's just kind of the opposite of what I did up on the top here. So it kind of depends on what I'm asking for. So they're both unit rates. Just depends what you're trying to solve on how you determine which one is going to be the unit rate. So if I want to know 24 meters, then let's go ahead and do meters over seconds. So 1 meter is 2/5 seconds. So if I have 24 meters, how do I find how many seconds that is? Well, what did I have to do here? It's always easy because it's always a 1. Well, I had to multiply it times 24. So I have to multiply this times 24. So then we have 2/5 times 24 equals 48 over 5. So x is equal to 48 over 5. And we're not going to cross multiply that. Not that you couldn't, but we're not going to do that right now. All right. So if I want to know exactly, I'm going to go ahead and take 5 into 48. Those 9 times with the remainder of 3. So 9 3/5. And that's seconds. Okay. All right. So I want to show you 2 things that we did here. So we talked about 2 different ways to do a unit rate, right? 2 different ways to do a unit rate. We did the numerical work and the algebraic work over here. And over here, we did a 2-dimension modeling, right? So that's part of kind of our learning cycle. Now, I'm going to show you a different way and then I'm going to talk to you about a few things I'm going to come back to this in just a few minutes, but let's talk about multipliers. All right, so I need to get a different sheet here. I'm kind of running out of room. All right, so when we talk about multipliers, it's another way. It just doesn't use a unit rate necessarily. Well, there's a connection there, and I'm going to see if you figure out what that is. So what a multiplier is so when we have our ratio with 5 meters to 2 seconds, we're going to just do that same thing. What we really are going to do is we're just going to make this one group, this 5 over 2 or 2 over 5 as one group, and that's going to be our multiplier. So let's go and we're going to do the same problem again where we have 15 seconds, right? We want to know in 15 seconds and the same 5 meters to 2 seconds. So here's what you have to kind of recognize. So if I want to find seconds, all right, then what I'm going to do is I'm going to find my multiplier by taking 5 meters over 2 seconds. And that's going to tell me how many groups times, I have to kind of be sure I'm saying it right, how many groups times your multiplier is going to give you your answer. So what I want to do is I want to take, if I'm going to find seconds, then I'm going to take 5 meters over 2 seconds. Okay, so I have 5 meters over 2 seconds. Now, I want to take, and this is considered one group. All right, so instead of splitting it into 2, all right, instead of splitting into 2, we're just going to, like this, we're just going to make it one group. So, and I want to know 15. So this is 5 over 2 meters. Okay, meters per second, that's our group. I want to know, what if I have 15 seconds? Well, 15 seconds is saying 15 groups of 5 over 2 meters. Right, so we're going to take it times 15. And that's 15 groups. So when I multiply that together, do you see that I get 75 over 2? And that's going to be, let's see, that was 15 seconds, so that's how many meters. So again, it's the same answer that I get here when I go through and I do this. So I find a unit rate, and I take that unit rate times the amount of seconds, which is really the amount of groups, right? Like the batches that we did, same thing. Okay, but instead of doing this process to find down to 1, do you see the connection? Here's what 1 second is how many meters. And do you see what I did here? This is the meters unit rate. And students will hopefully connect that if you do this together. So let's look at the other one. So let's say I want to know 24 meters. Okay, so I have 24 groups. So the next one, I have 24 groups. And so if I want to find meters, then I'm going to do the seconds. I want to know the ratio of seconds. So seconds is 2/5. So I'm going to be sure and do my one group with the seconds. So my one group is seconds here over meters. So if I multiply that, then we just get the same 48/5 seconds, which is exactly what we did here. So I don't ever teach this as I don't teach a lot of multipliers at first. We just go through and do the unit rate. But then you can introduce the multiplier, okay, as one group. You're just going to write this ratio as one group. And then you can kind of talk about it, and they'll recognize that this one group is the same as the unit rate. And this is the unit rate for meters, and this is the unit rate for seconds. So whatever's on top, this is meters on top, that's going to be the unit rate. And this is seconds on top, so that's unit rate for seconds. All right, so there's a connection that you can do with the unit multiplier. Now, like I said, I don't do a ton with unit multipliers. I might at a higher level start doing more because we start talking about scalar multiplication, but I just wanted you to see that at your grade level in the middle school. I mean, it's up to you. I would be sure that they know the unit rate like this first, because this is really important. This is what they really need to get. And sometimes maybe it's kind of a cheating method to not have to do that, but you know, but it's still, it is what that's what it is. This is the unit rate. So that's it too, but I wouldn't introduce that till quite a bit later. All right, so that's multipliers. Now, when I was talking about looking back at this, where we have the numerical algebraic part, and then we have a two-dimensional, what I might try and do then is I might talk to students about, okay, well, let's do something in the classroom that's a little more hands-on, not just drawing a model. So I might ask, and if you were in my class right now, we would do this, but I might say, okay, let's take your left hand and let's write however many, do the first letter of your first name. So mine would be J for Jill. And I'm going to give you 2 minutes to write as many J's as you can with your left hand or your non-dominant hand. Well, no, I would just say left hand, with your left hand. So everybody's doing the same. So 2 minutes start, and they're writing all of their, you know, whatever their name is, their first letter, and they're writing that for 2 minutes. All right, so they get done, and I'm like, okay, so we're done. I got 40 J's in 2 minutes. Okay, so I got 40 J's in 2 minutes. Oh, well, so tell me, how many J's could I do in 1 minute? So they can look at that, and having already done this work before, they could do it how they want. So they might want to go ahead and put it into a proportion. They might want to draw a double number line, and you just let them do whatever they want, however they want to do it. So they'll come out, whichever way they do it, that 1 minute is going to equal 20 J's or whatever their letters are, however it works out for them. This might be a fraction, right? Because if this were 37 J's, then I'm going to have a fraction, and that's okay. That's a good thing. They see fractions both and whole numbers. All right, so once I know how many J's I can do in 1 minute, I would then say, all right, well, let's say I wanted to do this for 10 minutes. How many J's should I be able to do then in 10 minutes? Well, then they can figure that out. They're going to multiply by 10. They're going to multiply by 10. So 200 J's I should be able to do. And they think that through, and they figure it out on their own, right? How many they can do. And that's a prediction. And so what we've done is we've done an experiment. This is our experiment. And we came up with a unit rate. And that unit rate will help us predict values in the, you know, values that we want to know. And then we can find those values. Now, if I did this and I went to 1 minute, am I going to get 20 J's? Probably not, right? You're not going to probably be a constant, steady pace, but that's not really the point of it. It's just recognizing a unit rate and being able to do that. So you could have them do, I know it kind of depends on your class, so you could do jumping jacks. You could have a word that rhymes with rate. I mean, there's a million different things that you can do. You know, jump on one leg, or, you know, just have to depend on what your class can and can't do. So you have to keep in mind that you'll have some some students that may not be able to jump on one leg, so you may not want to choose that. But that's then bringing in some real world that they can do and kind of relate it. So what I would then do is, let me reshare my screen here, is take a look at something like this. I might put this up then. All right, so tell me if you see this sign, because this is something we see all the time at the grocery store, right? $10, so for Planet Fitness, it costs $10 per month, or it's $199 for 18 months, you choose. So I wanna try and figure out, well, what's the best thing here? So I'm gonna write this down here so I have it. So $10 for 1 month, and I'll show this to you here in just a second. Or it's what, $199 for 18 months. So what you might want to do is just pause this and go ahead and see if you can figure out which is the better deal. What would you want to pay at Planet Fitness if you were going to do this? So I'm going to come back here, and I have this written down below. So what's the better deal? $10 for 1 month, $199 for 18 months. Well, you can have them put it on a double number line. You can have them set it up as a proportion. You as a teacher can determine, or you can just say, do it on your own and see how they figure that out. So what I do know is I already have a unit right here. So 1 month is $10. So I don't have to do anything more there, but I need to figure out what 1 month is here. So if I want to know what 1 month is here, what do I have to do to get this number up here? Well, I have to divide by 18. Right? So when we divide that by 18, I'm not sure I did that. So let's see, let me just figure out what it is. So 18 goes in here, goes in. Now remember that we are talking about money, and we are talking about middle school students. So they're able to do a decimal and add a couple zeros. So they should be able to do that. So they wouldn't have to use a calculator here. I wouldn't recommend a calculator yet. All right, so 10. Well, 18 does not go into 10, so we put a 0 there, and we bring down the next 0. How many times does 18 go into 100? So it looks like 5 times, which would be 90. Check my arithmetic there, with 10 left over. So it would be $11.05. So that's what we would have here, which is $199 over 18, $11.05. So with this deal, it's 1 month is $11.05. So which is the better deal? $10 for 1 month. But people naturally assume that, oh, $199, that's probably going to be a better deal. Well, in this case, it is not. So that happens a lot in advertising, and when you're looking at data and surveys, and don't even get me started on that. So keep in mind, what is the better deal? And that happens a lot in the grocery store, this or this, so, and sales. I like to shop. So now, the other thing that I was going to tell you that I probably would do with a class is I might start them with this thing called, so mathsnacks.org. Mathsnacks.org is a pretty good hands-on activity. It's not actually, it's more digital learning. So this Ratio Rumble, I'm just going to show you. And so this is for iOS, but you can do it on a laptop, on your phone. You can, wherever you can do it. And it's free. The app is free if you want the app. But this is what it is. So again, it's iOS, and it's called mathsnacks.org. And there's so many different games on here that are really cool. And so this one, which is here, which is called Ratio Rumble. And they can play it on iPad, they can play it online, however they want to do it. And these printable resources are really cool. If you're a teacher, this is really cool for you, because you usually have to do lesson plans if you're filling out. And so this has the lesson plan all set out for you. The learning objectives with your ratios, your math vocabulary. This has it in Spanish, even better. The technology that you're using, because we always want to use technology with students. They love it. This is a precursor for students. They don't have to know anything about ratios. They can just go in and start playing the game, and they're going to get a concept of what ratios are. and equivalent ratios. All right, and then there's some bonus questions, and here's discussion questions that you can do with your students. These are great resources for you guys as teachers to have. And just put them in a book and just keep them, and you'll see, I mean, it's really, really cool at what some of these offer, and these are all free. So I'm not sure where to get back to that, but that's okay. So here, let me go back on that again, just to talk about it for one more second here. I'm gonna do. All right, there it is. Just gonna go right back to the Math Rumble. There we go. All right. And so again, so here, this will take you through it to kind of show you what the kids have to do. And accessibility, I mean, these are just all really important things. So it also shows the Common Core standards in grades 6 and 7, exactly the standards for Common Core that the students are learning. How to play the video, and then just some guidelines on how to do the lesson. So just, you know, I'll throw out different things for you that I think are really, really cool. And this is one of them that is a great precursor for students doing ratios. All right. Okay, so kind of what we talked about there then is that when we used that learning cycle, when we went ahead and did this 2-dimension, again, numerical, and then we talked about the real world here when we did some kind of jumping jacks or wrote our J's. That's kind of more the hands-on, more the 3-dimensional that we did. And then there's also the precursor that you could use if you wanted to do the ratio rumble. And students, I guarantee you, students are going to really, really do well if you're using this hands-on learning cycle and doing all these different options. Now, what I would probably expect of you on a test or something is that you can show me multiple ways. Now, how the ways that you show me, that's up to you. Or I may say use a double number line, or I may say show me algebraically. All right, so be sure that you know how to do those. But you need to know how to do that anyway, because that's how you want to be able to teach students. All right, you guys. Thanks for hanging in for this. That was section 7.3. So I hope you have a great day.